Hardware.Info TV wordt mede mogelijk gemaakt door OCZ, MSI en Asus.
In deze aflevering van Hardware.Info TV, de eerste router met 802.11 AC. Welkom bij Hardware.Info TV. Netgear heeft deze maand als eerste een router met 802.11 AC geïntroduceerd. En bij ons om ons daar alles over te vertellen is de productmanager van Netgear Europa, Lionel Paris. En aangezien mijn Frans niet meer helemaal is wat het geweest is, we're going to do this in English.
Thank you.
Lionel, thanks for coming to our studio. So I just said you are the first company to introduce an 802.11 AC router to the market. It's the R6300. It's already available, right?
It's available. It's shipping today.
Okay. So 802.11 AC, the next step in wireless technology.
Yep.
We came from 802.11b, we had a G afterwards, then N. AC is the next step. I think they kind of ran out of letters, so they had to pick a combination.
They changed the modeling a little bit. Now it's AC. This will be AD in the future, so A is the new letter.
All right. Tell us, N to AC, what are the biggest differences?
Biggest and first difference is the maximum speed you can achieve with those products. Today, with a dual band 11N product, you can achieve up to 900 megabits, 450 plus 450.
Yeah, 450 on 2.4 gigahertz and
exactly.
450 on 5 gigahertz.
Exactly. So with 11AC, you can achieve up to 1.750 gigabit, which means 450 in 2.4 and 1.3 gigabit on the 5 gigahertz.
Yeah. So we brought up some numbers on the screen. Yep. I think best thing to do is first discuss that difference between number of channels, number of antennas. So channels, 2.4 and 5 gigahertz, that's two separate ways a router can work, and each device that's connected to the router can choose one.
Exactly. So 11N is not necessarily dual band, that's a single band technology. The dual band is optional. But today most of the products are using dual band, which means 2.4 and 5 gigahertz running at the same time. So 11N today run at 40 megahertz bandwidth, both on the 2.4 and the 5. And hence the maximum speed you can achieve is depending on the number of antenna you can put inside one product. You get one, you get two, or you get three in each band. So then you go from 150 with one antenna, 300 with two, and 450 with three.
Yeah, and all these three antennas transmit simultaneously
and receive
to one client.
Exactly.
And to get these 300 or even 450 speeds, also your client device needs the same amount of antennas, being 2 or 3.
That's working exactly the same way on the antenna on the adapter side.
Yeah.
You have the same speed and the same number of antenna. The only difference is an adapter cannot be dual band. It's a single band product, so it works either at 2.4 or at 5.
All right. Then we go to 802.11 AC, the new standard.
Yep.
It's essentially a single band standard because the 802.11 AC standard only works at 5 gigahertz. But still your 2.4 gigahertz device still works because the devices also do 802.11n as some kind of backwards compatibility.
Exactly, and that's the main difference between when we switch from G54 to 11n at 300, we kind of lost that compatibility in the way. Here it's not happening because the 11.2 AC is working, all the benefits is happening on the 5 gigahertz, but we kept the 2.4 just to maintain the compatibility with all the existing devices that we do have today, which mostly are using 2.4.
So I can have a 2.4 device transmitting or getting data from the router at the exact same time as an 802.11 AC client from the same router and both at their maximum speed.
Exactly. Yeah. Or even a dual band adapter today, which can work on 5 gigahertz, which will be only 11N, but that will work fine on the 5 gigahertz band as well on AC.
Yeah.
It's backward compatible 2.4 and 5.
Yeah, and then in that 5 gigahertz band, that's where the magic happens, and that's where a lot of bigger numbers.
So the bandwidth that we're
11.
using between 11N and AC is moving from 40 megahertz to 80 megahertz.
Yeah.
So you multiply the bandwidth by 2.
That essentially means you take a bigger chunk of air where you can transmit.
So if I have to take an image, you can imagine an highway with 2 lines, and then you have an highway with 5 lines or 6 lines that you can use at the same time. That will be the most appropriate image we can use for that.
Yeah.
And then in top of this, we're also changing the modulation from 64 QoM to 256, which means using the same images, you're having one passenger in each car. In 11N, you get 4. And this is how we achieve a maximum speed of 1.3 gig instead of 450 if you look the current 11N.
Yeah, and then just as with 802.11n, we still have that story of different numbers of antennas. You can have 1, 2, and 3 in this device.
It's working the exact same way. You get 1, 2, 3. In fact, that technology can go up to 8. But today, the solution we have is a 3 antenna solution. Yeah. So the lowest speed on 11NC will be 433 megabit compared to 150 in 11N. The medium,
so 433, that's on 5 gigahertz, 80 megahertz channel, 1 antenna.
1 antenna. 2 antenna is going to be 867 instead of 300 compared to the 11N. And 3 antenna will be 1.3 gigabit instead of 450 in 11N.
Yeah.
So then you can see the gap.
And that's why you call your device 1750, because you say 1.3 on the 5 gigahertz band, plus and the normal 450 for 802.11n on 2.4.
That's the evolution.
And we were talking about that 80 megahertz band. That was like putting 4 cars next to each other on the highway instead of 2. Yeah. We're going to 160 in the future. That must be like 8 cars next to each other.
Yeah, that's
like
pretty
the biggest highway ever.
That's the same logic. So that's part of the standard today. That's the optional piece of the 11.2 AC. We don't have any chipset solution today covering that spec. We're expecting to get solution next year that will starting to use that technology.
Yeah. So one of the big advantages of 802.11 AC is these bigger speeds. Also, the current solution already can get that higher speed. But the other thing is you also have an advantage of having multiple antennas. Also, if you only have clients that only use one antenna.
So today, most of the devices we use are either 2.4 and 5 and roughly 11N. Yeah. So the end user benefit by having this product right now in the house and replacing a current existing 11N solution will be to be able to address 6, 7, or 8 devices simultaneously. So for example, you can have a 7 HD 1080p video streaming at the same time wirelessly, which you cannot perform today with even the top of the 11N solution. So the end user will have an immediate benefit using current product because the wireless is not going to be the blocking point anymore. Yeah. It's not going to be the bottleneck anymore because we're starting so high compared to the device we have today, then you can assume more devices connected at the same time. Yeah. Hence, video is the perfect application for that.
But so what you're essentially saying is that an 802.11n router can, at one single point in time, can only transmit data to one client, or to maximum 2 if you use the 2 channels. But with 802.11c, every antenna can set up its own connection to two separate clients.
Each number of devices you have in the field. So and they can do this in both channels at the same time.
So inside here we've got 3 antennas for the 5 gigahertz band. So 3 clients at 5 gigahertz get data literally simultaneously, not time slot, you for a second, you for a second, literally simultaneously.
Exactly. And the demo we did this morning, we were streaming at 6 different computers on the 5 gigahertz at the same time.
Because this morning,
on the 5 gigahertz only.
You had like the introduction event, and that's where you showed it. 7 clients, full HD video.
Full HD video at the same time.
And a lot of journalists with wireless smartphones in their pockets, and still not a problem.
It's still not a problem. Well, the 2.4 obviously is more noisy, so the 5 gigahertz was working perfectly. The 2.4 was starting to be a little bit flaky because of the wireless phone in the room. But this is also one of the big differences. Switching to 5 gigahertz, that is the advantage. Because you don't have that noisy environment. Because we all get smartphone, we all get Wi-Fi, we all get tablets. So when you have 20, 25 of device in that same room, obviously you are in a big noisy environment.
So that's also the advantage you have at home, right? If your neighbors probably have a 2.4 gigahertz
Everyone
network.
Has 2.4
so if you upgrade to 5 gigahertz first, you have the advantage of having all the air for yourself.
Exactly.
All right, then the device, the R6300. So it's the first 802.11 AC router on the market.
Yes.
Available right now.
Available right now. We're having a complete lineup, so we're having this product available today. It's having a 4 gigabit port switch in the back, 2 USB port. We're having all the feature we're having traditionally on the high-end routers, which means you can share a printer, share a file over the USB port. It can act as a DLN server at the same time. Of course, you can control your device using our new Genie mobile application. You don't need a CD to install it. The setup is very easy on this device. and of course, and it's backward compatible with previous generation.
And you gave this device both on the router itself, but also on the box, this gold tagline. And then I think there must be a silver and a bronze one.
Yes, exactly. So the gold edition is 1.750, and the silver edition, which is going to be the R6300, is a 1.2. So what we did here, we just remove one antenna on each side, reduce down the speed for those who don't need to get that fast. It's a 300 solution plus a 900, and we remove one USB port. And the idea was to reach a more aggressive street price and still having AC solution embedded into the router.
So the suggested retail price of this product is $199, which is, of course isn't particularly cheap for a router.
Exactly.
But if you look at the future, when do you think that 802.11 AC products will be just as affordable as 802.11n routers are right now?
I think it's going to be pretty cheap because the standard, we're looking for a final ratification of the standard by CES next year. So this is in 6 months from now. So the standard and what we're having right now is pretty mature compared to what we used to experience in the 11N time.
But 802.11n took years, right? Everybody said, you know, it's almost finished.
Yeah. So the situation is quite different because I think the whole market, EEE, the vendor, the chipset vendor, we all learned from that experience, which was not good. And then we make it happen more faster. We agreed more in advance. Then the standard is more mature today. So we're not going to make the same mistake. So that's the number one. The number two is from an 11N standpoint, I think the first lineup, which will die soon, will be, of course, the high end of the 11N today. Because we were going to be able to reach those speed with the entry level of the 11AC. So those products apparently will disappear somewhere next year. And then the entry level of the 11N, the 150, I think this will disappear soon because the 300, as a matter of fact, will drop down. And we will end up having 5 range, I think, next year at Netgear still. But then the entry level will be 300, then 600, and then we're going to have 3 flavors of 11AC. That's probably the future. And then final question, you say the final version of the specification will be finished like around CES time, so January next year. If I buy the router right now, how can I be sure that this router will work with the final standard next year? It will work for sure this time because we don't have 2 different standards. That was the case for 11N. We have 2 camps basically fighting for each other and getting that standard approved. We're not in that situation right now. But so you give a 100% guarantee that if someone buys the product right now, in January he can download a new firmware that's 100% up to the final spec. Without any doubt. All right. Thanks for coming to our studio. Thanks for having me. En complete review van die Netgear R6300 is spoedig te vinden op Hardware.Info. Dit was weer Hardware.Info TV voor vandaag. We zijn er iedere maandag, woensdag en vrijdag. Bedankt voor het kijken en tot de volgende keer.